Because we got some people at the back, so can you just move in as far as you can?
Yeah. Sorry, it's not the best place to pop you. We're all ready? Hello. So I'm Tamara. I am one of the micro team leaders. So here we have 2 micro team leaders. Dawn was unfortunately away today. What we're going to do is we're going to split you into teams of about 7 and we're going to take you around the whole micro lab. A bit of background into Hills. We've been around for 30 plus years. We are technically a commercial laboratory, however we're still family owned. So Roger and Anne Hill started the company in Hamilton as an ag lab in their basement, and it's grown pretty much into a giant unicorn. There's about 700 of us. We have our satellite site, so Christchurch is technically a satellite site, but we are about 70 plus staff. Micro alone, there's about 30 of us. So here we do asbestos, we do chemistry, we do ag, but we are definitely mainly the micro side of things. Our micro lab in Christchurch, we run 365 days a year, so Christmas, public holidays, 13 hours a day, so obviously big roster to juggle, but we like to try and train everyone into all areas so that they're well equipped and knowledgeable for the whole lab. We have Hamilton, which is our main site. We have Bay of Plenty, so they do, obviously you guys are doing micro, but they do kiwi fruit testing, we do wine testing in Blenheim, we have asbestos sites in Auckland and Wellington, so we're pretty much all over the place. Right, that's a little bit of a background into Hills itself. Shall we split up into teams and we'll start taking you through? So if we split into teams of about 7, so 4 groups would be great. What we're going to do is we're going to take you into our micro waters lab, we're going to take you into our food lab, our PCR, so our PC2 area, and our REITs lab. I've got a few people in different areas for you, so if you have any questions for them, sing out. So Waters, Alexia has started off as a technician only about 13 months ago. She's now assistant technologist, so she's going to talk to you guys in Waters. In food, we've got Barbie, so Barbie's, you would know Barbie, right? She's been here for 20 plus years, so she's longer than me. So Barbie is extremely knowledgeable, 20 years plus just in Hills itself. She's a CSM, so she's dealing with the clients, working out activities for what we're going to test. We also have Carla, so she's a senior technician in the micro lab. She's also a KTP, so she is responsible for reporting out all our documents and all our clients' reports. And then you'll have Marissa, so she's a CSM too, but she's got 8 years experience. She was also the previous team leader in micro. So if you have any questions, ask away, because all of them are extremely knowledgeable. Right, have we got some groups?
We'll have the first group here, because this one needs to...
Cool, so if we pop you into here, and if one group can just pop into the waters lab then, because there's 7 of you to pop into there. Yep, you can go straight in. Alexia's in there for you guys. And Barbie! Welcome. Right, and if you...
Just 7, please.
Just 7
So,
pop. How many?
so yeah, not you, not the last one. 7.
You guys come along too, we'll split you. We're doing it a little bit. I would have liked to take
Go. Sorry. How does the team go with
you guys want to come through and I'll take you to the next area. Come along. Found them.
What?
It's a little bit of a rabbit warren, eh? Come through, guys.
Well, it doesn't help that I haven't got such a collection. So.
No, neither do I. Come in. Sorry, guys. Come through.
And they were processed.
Oh god, there's things in here.
And after all the process is done there,
We've got 7 minutes. Yeah, come through. You might want to come in here so you can all fit.
come in.
Yeah, jump in. Come through.
What smells bad in here?
Everything smells bad in here. So that's something you get used to being in rates. So everything in here has been cultured, incubated 24 hours, 48 hours, 72 hours. So that's why it smells bad in here. So have you seen much of reeds or read any agar as such? No?
Agar play?
Yeah?
Yeah.
So this one here, have you been to the waters lab?
No, you're first up.
Okay.
It's very confusing.
Okay. So in the waters lab, they do filtration on this agar, and that's what the result looks like when you do it in the reeds lab. So this is MFC, and we filter different types of waters, surface waters, different types, effluents, drinking waters, and anything, if it's a drinking water, you shouldn't see that. So that is, blue colonies are fecal coliforms on that agar. They also do quanti trays. We read quanti trays in here.
Do what trays?
Quanti. So this is a special type of test.
Toily trays. Oh wait, no.
QT. So we call it a QT tray. So that is what we read here in reeds. It comes from waters. So this is probably, let's say, a surface water. So anything yellow is a coliform, and if it's E. coli, it will fluoresce.
Sorry,
Can I
guys,
just see
what it looks like?
Thank you. You want to see what it looks like in there?
What you got here?
So that's fluorescing, that's E. coli fluorescing.
So what's having a fluorescence is the same for the
Yeah. Yeah, sure. I'll do a lot of you away. So that's what we do in reeds.
I just like choose
So
Yep.
media, so this is a changing color. So anything, the media is initially purple, and it changes color if there's E. coli in it. So in reeds, it's basically counting colonies or changing color of media. That's the basic. Yeah. Any questions?
how was that sample captured?
So you'll see in waters, they'll show you how it's done. So it comes as a little tray and it's open. So you pour the water in and we put it through this machine and it seals it. Heat seals it.
So this sample needs to be stored for a long period or just keep fast?
You mean the tray or the actual the tray? The tray is a 24-hour test and we have to read it. We read it the next day. And we don't need to store it. Once we read it, we can throw it away.
What was the title of this?
This little area here, so we call it, it's been given many names, but we call it the reeds room. So we read all of the stuff. Basically, everything that's tested on that side comes out here, and we read color changes and some colonies. So we have another method. You've seen the agar plates before. These have taken over agar plates in some cases, and instead of counting little colonies on the jelly, they're little red dots. So this is much easier to do. Do you want a photo or anything like that for? No? So that's for APC, and these little guys here are for E. coli. So the blue colonies are E. coli.
So if the E. coli contains the sample, it will be changed the color image.
For this one?
Yeah.
No, it's blue. So it's straight count. You can see it right away. So the blue colonies
Yeah.
are E. coli. So if you want your sample to be clean, you don't want to see anything on it. So that's what it should be like. It's nothing there. So if you see any blue colonies, that's not what it should be. And if you don't want to see anything on these APCs, it needs to be clean like
And why there is different color because
that one's a totally different test. We have different tests for specific sample types. So that's for water test, and this one we've done it for food. So it's meat, bakery items, all sorts of stuff.
I was having a look on Lab System, which is a system that we use. We have about nearly 180 test methods here just for micro, so a huge amount of tests that these guys need to learn and then be able to read. Be about 180, I think it was.
Yeah, it's quite a bit.
Huge amount. All done differently, eh?
Yeah. So this is what we call the traditional method, and that's physically counted. So that's just a general APC test. Any questions? Anything that's caught your eye and you want to ask what that is? No? No? Have you guys come across things like this, like agar plates or you have? Yeah. For your labs? This one? Yeah. This one. So that's purple originally, it's a changing color for positive, so that's
Try and move on. Do you guys have any questions? Let's swap into another area. Yeah, all good.
nice to meet you guys.
Thank you.
You're welcome.
Go on that way.
哪一快到了，它在这儿。
Yeah, we're going to go into the waters lab. I'll give them a bit of a chance. Yeah, that's still going.
奇怪，哪一呢？
Oh look, they're going to move on. You jump in. How far into your studies are you guys?
Second year. No, third year actually.
Nice. How long? 4 years?
3.
Oh, nice. Yeah. What do you want to do? Do you know?
Not sure yet.
Yeah, it's very hard, isn't it?
Yeah.
Expect to have everything pieced together.
OK，哪一快到了？
快到了，我们快结束了。
我随便
看水珠。
So can you guys pop into the air? Alexia will take you. She's ready for you
来，
guys.
让我
And if you guys pop into that door.
Hello，这个
How are you guys?
Fine.
fine。
Good? Are you all doing the same degree?
Yeah.
Yeah.
Yeah. Cool. Well, this is Waters. Welcome. Health Laboratories has the largest range of testing services for water in the country. What we test in here is the microbiology side of things. So we're testing for E. coli, other bacteria using a range of different methods. All the chemical analysis is done in a different part of the lab, which I don't think is included in your tour, unfortunately. You guys are all just seeing the micro stuff. Cool. So we have a range of different tests going on at the moment. Ashley here is testing for Legionella in waters. Legionella. So Ashley's testing for Legionella in waters. It's quite pathogenic photogenic. You don't want to consume it, so it's very important that we're doing accurate testing. Paria over here is doing membrane filtration, so using this method we can test for a range of different things using different media. You can see that the petri dishes are blue, so we're testing for fecal coliforms and E. coli. Over here I am doing some quanti trays, so I'm testing for coliforms and E. coli but using a different method to what's going on here. I'm going to show you how to do a quanti tray. So we light our Bunsen burner for sterility. You guys are more than welcome to come around this way so you're a bit closer if you like. There's some space on the side too. Is there any questions so far? Or are you guys all good? You're all good? Okay. I'm going to grab a sample from the fridge. 30.1. So I'm scanning it in and I'm scanning under my name here. This is all for traceability, so we're an IANZ accredited lab. So if IANZ are doing an audit, we need to be able to show them the process from start to finish, who did what, at what time, where the sample was. So put in all the relevant information. Computer spits out 2 stickers. I'm going to put one on the tray. And one on the container the sample's going into. Give it a shake to homogenise the sample. Flame the rim and pour off 100 ml into here. So I'm flaming it just to keep the whole area sterile. Right, now I'm adding a dehydrated media here. What's going to happen is this gets added to the 100 ml of sample, it gets incubated overnight, and the bacteria in here are going to metabolise the media in this to produce a colour change and some fluorescence. Shake that up until it dissolves. Once it's all dissolved, give it another shake. Once it's all dissolved, I'm going to use my barcode checker again. Scan that barcode, scan that one. I'm looking for the tick, and that's telling me that these numbers match and there's no sample swaps happening.
No sample swapping.
Yeah, that's what the barcode checker's for. That goes into the tray and is fed through into the machine. The machine is very hot and it's going to sandwich the tray together to keep the water in.
What's the name of that ingredient? That dehydrate?
Poly 18.
Poly 18. And is that the ingredient to make the water sample have fluorescence effect?
Yes, if it has E. coli. E. coli is a bacteria that eats up all the media and then it will fluoresce. Yep.
Yeah.
So you can see here that the water has filled up all the wells, and that's what we're looking for. And the way we get a count by this is doing some statistics. Wherever my piece of paper's gone.
I'll just take a photo of on there.
Yeah, so basically tomorrow we're going to pull this out of the incubator, count how many squares have changed colour, how many fluoresce, and then do some statistics to figure out what that means for how many colonies we have in the environmental sample. So if you guys head round that way, where Paria is. Crap, we're coming Paria. Yeah!
Sorry.
Don't
Sorry.
What she's doing is incubating the membrane filtration stuff I showed you over there. So that's going to be incubated overnight, and colonies are going to grow on the filter, and we'll be able to count them tomorrow. Do you guys have any questions about water testing?
About the counting part.
Yep.
If the sample was it is contaminated by E. coli, and why should isn't it means all the samples why the trail has some fluorescence effect in specific area? I mean, it's like, isn't it if this water is contaminated, shouldn't it be all have the E. coli?
If it has high counts of E. coli, then the whole thing will fluoresce. That's a very good question. Sometimes you don't have that much floating around, so you might only get one colony in each well, so only that one well is going to fluoresce. But if there are higher numbers, you're going to have more of these that change colour.
After the trail was encapsulated, is there a incubate period for the microorganisms?
Yes, I will show you. Start. So again, I'm scanning. Oop, wrong one. I'm scanning, so it's all traceable. I'm scanning my own barcode, so people would know it's me if there's any questions. Scanning the incubator. I'm going to pop in here now. So anyone can look on the computer to see this sample got incubated at this time by me. This is some controls that we set up this morning. So you can see the colour change. If I had a UV light right here, I could show you that it's going to fluoresce, but I don't have one. They have one in the path room, which you're going to see later.
Oh, we already saw that.
Oh, you've already seen it?
The read room.
Reads room, yeah. So they have the UV light in there since they read everything that comes out of our incubators. Does that make sense?
Yeah,
Yeah.
being there.
It's a lot of information, right?
I'm just taking.
Could you? Cool. Alright, so lots of things could influence the number of E. coli's or coliform or whatever we're testing. So depending on like what's around where you're taking your sample, so you're taking your sample from like a river that's surrounded by farmland, could be quite dirty. If there's regenerative planting around the side of the river, it might be a bit cleaner. Especially after rainfall, actually, you're going to see elevated numbers of different contaminants. Yeah, that's why it's important to our testing. Cool. All right, I'll take you through to.
Oh, perfect timing.
Oh, perfect.
Okay.
Thank you.
Thanks.
Oh.
哪一来的？
它过后有时候会变色，荧光灯。
对啊，照了荧光灯嘛。
对啊，那荧光灯怎么样就会变色呢？变成那个蓝色，又不会一般。
有大肠杆菌污染就会变色，然后变色的原理是因为这个东西的染色。
哦。
This is a bit more meatier than the other areas, so but I'll give you a little bit of a rundown. So sample section, which is where we started before, what they do is they register all of our samples and they come in here. So sample reception need to know water side of things, food, asbestos, chemistry, so really knowledgeable. It takes, I would say, 6 months to be okay and about a year to be comfortable what you're doing in there. So they need to know things like waters need to be done within 24 hours, so they need to know that. They need temperature requirements, so they might need to know a sample needs to be 4 degrees within 6 hours or 8 degrees within 24 hours, so a lot of information about that. Once they register them, they come in here, or all the other labs anyway, but for micro the paperwork comes through, and what Suda's doing, sorry again Suda, I'm using you, so she at the moment is prepping all the samples, so you get the paperwork, it will give you what tests need to be done and how much of the product we need, so it could be anything from a cake to mussels to cow's tongue, so we get nice stuff in here, we get not nice stuff in here. Depending on what she's testing for, she'll scan it onto a worksheet and it prints out how many grams on the sticker. She then works out what if it needs to be filled with any media, so any broths or diluents, and then it gets prepped and goes onto the plating side, the tempo side, or if it's salmonella stereo, we do that part here and it goes straight into the incubators. Oh yes, perfect timing. So Barbie's just taking the next group through. It shouldn't be too long. Yeah, you can hop in here if you want. Give you a bit more space.
Oh, hello! Oh,
Thank you.
You've done all of that
I've done
part.
a bit of chop. Yeah, you've got the meatier area.
Cool, okay, rightio. So, you've got your sample homogenate that you've chopped up down there, and now we're going to take that and we're going to put it onto some agar plates and things. So did Timo tell you about when we do enumerative testing versus when we do qualitative and quantitative testing? No?
Okay.
So some things like Salmonella, Campylobacter, Listeria, usually we're not allowed to have those in food. So those tests would usually be done as what we call a presence-absence test, or in a qualitative test that says yes, that organism is there, or no, it is not. And we want it to say no, it's not, because that's what we require in food. So there are other tests like Staphylococcus, Bacillus, some of those other things which aren't quite so pathogenic, that we're allowed to have up to a certain level. So we're allowed to have up to 100 or up to 1,000 per gram, and that's acceptable. So those are done as a quantitative test. So this area here is where we do all the quantitative testing. So this is where we do the testing that we're giving the customer a count. So this is how many organisms you've got per gram of food. So there's lots of different ways of doing it. So we've got pour plate, which I don't think you guys are familiar with unless somebody's seen these before. So essentially you take your homogenized sample, you put a mil into the empty petri dish, you put some molten agar in, and you let that set. And then that basically becomes something that looks a little bit like this, that you then incubate. And the organisms grow inside the agar. And then you've got a lot of things that we do as spread plates, where we take an agar plate that's already set like that one, and we put the sample on the top of the agar and we spread it around, and then the organisms grow on the surface. So one of the advantages to doing this kind of testing is that you can see the morphology of those organisms. So if you're doing any kind of ID work, you can see whether they are big or small, whether they're smooth, whether they're rough, whether they're shiny, whether they're dull, if they've got different colours. So that automatically is creating a dilution by making it smaller.
Cool.
Yeah, it's pretty cool. Yeah.
Useful.
Yeah. So this is called Tempo, and it's actually, we're currently the only lab in New Zealand that's using it. So us and our Hamilton lab as well. So we've got a micro lab in Hamilton too. So yeah, there you go. That's kind of plating in a nutshell. Now
And
hopefully
for the traditional MPN way, what's the glass slab in the tube?
so the little upside down test tube,
I'm not sure what it is.
Durham tube, the one that looked like a little test tube upside down.
Tube.
Yep,
Yeah.
yep.
What's that for? Yeah.
That one?
Yeah.
So that's called a Durham tube.
Durham tube.
Durham, D-U-R-H-A-M,
Alright.
and it's for catching gas. So the organisms that we're looking for in this test are gas producers. So in a tube like that, the best way to look for something that produces gas is to put something upside down to catch the gas. So when they produce gas, the gas goes up inside the tube and you end up with a gas bubble on the top.
Got it.
It will kind of look, if you can see past all of the other bubbles that I've got on the outside now, because I've just made real shit. There's like gas bubbles up in the top of that little tube now.
Yeah.
It will kind of look like that, but not really.
Okay. Let's see.
Yeah.
This is not a test for E. coli, right?
It can be. It can
can
be.
be? Oh.
So this is a test for the coliform group. So it goes through a couple of different steps. So this is what we call a presumptive step. And when that's positive, we go, right, how many of those look positive? And then we take those and we say, if we want to look for total coliforms, we put it into this confirmatory broth. If we want to look for fecal coliforms, we put it into this different confirmatory broth. And if we want to look for E. coli, we take it into another different stream. So there's three different, after this, it can go three different ways to produce a result for total coliforms, fecal coliforms, or E. coli, or all three. Yeah. Okay? Right. Hopefully, Carla is ready for you guys. Ah, she is. Come this way and Carla will look after you. Keep on going. She's not looking at you, but she will be in a second. Go on through.
DJI area.
Yes, PCR. But this is the PC2 level because it's all pathogens that we treat there. So we process our samples in that area, the one that you have just here, and we incubate our samples for maximum 24 hours. And after that time, they get pulled out from the incubator and they're just bring to this area, the PC2 room. So the DNA process extraction starts there. Once the samples of the DNA has been extracted, they are put in the registration plate for PCR mix, and then they get run in these computers, the PCR machines. After 40 minutes approximately, around 37 cycles, we get the results here, the amplification graphs. So this is what we want to see. Sigmoidal exponential curves. That's our positive control, and you can see the graph there. It's nice, sigmoidal. It has the exponential after so many cycles. All the DNA is replicating, so it produces the curve, right? That's the positive control. So a negative control will be this. Just the IPC amplification. That IPC stands for internal positive control. It means that our mix has worked and our broth, the enrichment broth that we use in the sample processing is working. And of course the temperatures and all the process work perfectly. So that's what we see there, and our DNA control as well it works. So it has amplification for DNA and amplification for positive control. That's for listeria, and in this case, and then this is for salmonella. So it's just the same amplification. So that's the positive amplification, presence of salmonella or listeria or chronobacter. We test as well for Legionella, but only for Legionella confirmation, and we do top 7 as well. But the top 7 part we only do in this area because it's the 0157. It's so dangerous. We don't want it outside here. We just keep it in the PC2 area. Yeah, that's it. Any questions? We receive some different samples. So we receive sometimes environmental swabs. I don't know if you have done that in uni. Or we receive food samples as well, or chemical samples for cosmetics, and any type of food. We have validated our test, so we can get an amplification for any type of food that they send. So it can be nuts or sauces, fruits, salads, meats, dairy products. No questions?
Very clear.
But you will be back to uni soon enough. What time is it? Oh yeah, it's lunchtime. liking the experience. It's raining outside now.
Is it actually UV in here?
Yeah. Now I think they just need to turn on the light, so you're going to see that it's on.
So it's only authorized access allowed in here, right?
Yes, and they will have to change the laptop as well because we cannot use the white laptops. They use the blue laptops there as an extra measure of security. So that's where we do our top 7 controls and our Legionella controls as well. Nice and easy. And this is where we prepare our PCR mix. We dispense our PCR mix. So I have that's why it's a food. Nothing is left in that area. It's just we use special sleeves and the gloves, of course, because we don't want any DNA inside it. It's just for our PCR mixes. Are you doing food technology or
Food science.
second year?
Yeah.
And you can see
So what is the means of this chart?
this shirt one.
Where was the mean? What's the mean?
So it means each one of those is a cycle of the PCR, right?
Yeah.
So at the beginning there is only maybe one cell that it's the DNA replicating, and after cycle 20 something, or in this case 16, 17, it starts going more and more and more, so the machine can read the fluorescence, because that happens here, right? So that then starts producing the graphs. So the graph, I would like to have one that it's producing all the graphs. You can see the curves advancing every time a little bit more, a little bit more, a little bit more. And then they need to cross a threshold. So here is the threshold. If the amplification doesn't go up this threshold, we cannot accept that result.
Okay.
And the IBC as well, it has a threshold. But all of them have crossed at a good cycle, 20-something cycles, so that's good. If it's too late, that's not good. It means there is something wrong with the sample or with our mix, our process, or the technician maybe missed a step, or they didn't follow procedure, so we have to do it again. But this is what we want to see. All targets, so yeah.
So how much the time that if we make a product, how much time will we need? About approximately about 1 hour?
1 hour, yeah, 40 minutes.
40 minutes.
Like 37 minutes or something, yeah. And then it produces the graphs. And then we have our final result. So we export this into a worksheet, and the worksheet will say positive or negative, and that's the result that we send to the customer. So you have been in reads already?
Yes.
Yeah. Or I think you can go now to waters, I think. Have you
We
been in waters?
have been there. How
Oh,
many?
you have done the whole thing?
So all this area.
Waters, foods, PCR, and reads.
Yeah, this
That's
for
it.
partner I will.
You're done. Going for lunch now. Yay.
Thank you.
Thank you.
Wow.
So that's pretty cool.
造型有点别致。
啊，
哎，你是怎么过来的？
好热。
开玩笑吧？你公交过来？
没有，叫林肯里面认识的，开始这样的。
嗯，叫了谁？
林肯里面宿舍认识。
哦，
哦，我要
开玩笑。
对对。
我发现他们给每个仪器都起了个名字，
是吧？
每个实验设备都写了个卡通，然后呢起了个名字，
是吧？
对啊，
它每一个
一个水域锅叫阿宽面，
不抽烟。
那个，
对啊
你没看那个冰箱上面有一个贴了一个 Mr. Freeze，然后贴上蝙蝠侠里面激动的人。
对的，冷冻博士。对啊，而且
他们每一个东西都有。
企业文化挺好的。
这个100刀。
哎，没事。
Thank you.